platform. So we have a couple partners that are, got a couple of customers that are, have some pain points and so I'm trying to learn a little bit better.
Steal the beer out of
it. Sometimes your best part is to shoot things to the customers too quickly. Then
Clint, you should be getting an invite for the hangout shortly.
you gotta learn from different angles. So, trying to see how that, the topology of what an optimal configuration comes in where you start having enough data coming off. And that is exactly what's happening. Our architecture is kind of unique, so you can actually connect the storage to both the index and the search.
There's one. What's up with that today?
My name is Juan Montoya, and I'm here to.
I was going to say, hello, my name is
One of my good friends in Dallas.
12.
And managed their entire infrastructure, including all the
Belongs to Matt Green.
Splunk and then T-Mobile phones.
None more.
And he had Splunk through all of
Okay.
T-Mobile, including the German Deutsche. And
Stop.
so he had a pretty beefy.
You want to start at 7,
pretty
roughly?
varied. I mean, he had
Good.
Sure.
Do you take that long?
terrifies
Okay.
changed depending on who your co-partner is.
I'll put.
Which is cost per byte and cost per applications, you can buy applications anywhere.
Just one.
And they, you know, even though they're only paying whatever for cost, if you're on a code share or a lease share or a, you know, XPad or whatever changes their cost per. So he did the whole infrastructure for that, and then after doing that for 5 years or whatever, he decided to start using company. Don't do that now. There's no around performance to
Oh, you can deal with
performance
that.
to people support controls.
Hi.
Splunkster.com.
Pizza, a few beers over there. I had to go raise someone else's kitchen and bring you beer.
What's up with that?
No, it's so not Splunk.
Splunkster. I'll be right
It's when baseball season is back. It's ridiculous.
It's not after 6, it's plenty of.
Yeah, there's
Yeah.
not a street.
I'm sure
Thank you.
leave anything as far as.
Yeah, don't. Alright, I need to connect this somehow to the stream. Forgot how we did this before.
I have to send you an invite.
Yeah. Oh, you have name tags.
During the presentation, Clint's going to be sharing his screen, so no one's really going to see
Okay, but
it.
you would said that it would be fine to
We can treat that.
eventually want to do that. I'm happy to not do that anymore.
Do you have the means to record it
It's audio.
outside of? Do you have like?
one machine.
Are you on Windows? Machine?
Yes.
Do you have like Camtasia or something?
Well, this comes with its own.
Oh,
Yeah,
perfect.
this has its
Okay.
own own.
If you can, so record it,
Yeah.
and then I can actually cut them together.
Yeah, I don't think I streamed it last time.
Okay. Yeah, I'll edit it together.
To get over the
Look at me.
Yes, I'm totally recording you eating now. I'm not recording you eating.
I gotta go on my right.
I have a little cube as well. That Polaroid cube.
I haven't opened it.
I took the cube to the mini gaming con we had last weekend because one of my friends really wanted to see us play D&D. And it turns out it records 5-minute segments of video. You have to run the next one together. And it died after 2 hours. But you know how long it takes to kill camera?
It's been great.
Okay, put your name and your company on there. And make a quick note. Becky on Yahoo. All right. Welcome back. Thank you. Joel. Ah, cool. Using my own keyboard. Hi. taken away.
Thank you.
The name and company, yes. Somewhere in here. So awesome. Pizza's on the other side.
That doesn't mean I know anything.
Oh, nice. It's not a requirement. Yeah. I'm Rachel, by the way. Oh yeah, I'm the community manager here nowadays. Russ, you have a name tag? He defies name tags. Anywhere you like.
I run Ubuntu. I can't figure out the Mac keyboard.
Ubuntu.
Too hard to
Such a
do.
rebel, man. I love how you don't conform.
The worst is Carl, who has Ubuntu on a Mac. So whenever I have to type on anything, like I go into like my pathetic Mac keyboard mode, and then it's all wrong. So,
You need a System 76 machine.
yes.
That's my next purchase. Built specifically for Linux. Have you ever heard of them before? System76.com. Check
Yeah,
them out.
there's another shop
They got
that did
fantastic machines.
Linux specific builds that I looked at before about that guy. 2011. I kind of went there. Wow.
Control.
So,
Zoom.
why should I share my screen?
Yeah, but I'm
Yes,
not.
I'm
I'm just
recording
hiding
your
you for
face,
now.
but, you know.
Right now, I just have a welcome screen, just letting people know we're eating. You start.
We're not careful.
So we can grab a water.
Oh yes, absolutely. Help yourself to anything in that fridge. I just had to go raid the computer somewhere else.
See if I'm on another window.
Yeah, give me 1 second.
I never know whether if I go to another desktop.
Are you gonna paste the streaming link to the group when you're done?
I can, yes, I will do that right now.
Oh, they replaced that giant projector. I think. Oh, maybe that is still the old one. Like last time, it sounded like it was going to take off. The jet. I'm looking to your front row.
With the,
This thing?
so I plug into the thing, is the control back there? Oh, you got it, okay. It was back there.
It's just a different kind of control.
Okay, I'm eating one slice of it. Might be over until second dinner.
Laptop detected.
Probably need it.
Shovel meter in the back.
The goal is to be smarter than the equipment you operate.
Yeah. Fortunately, they don't make any sense.
Try to make their version.
Hey, how's it going?
Being very well.
Oh, yeah, you-
I'm excited. Last time I was,
You're the like edge case that no one knew about.
Exactly. So,
What? Thanks, Mom. See, there's pizza. What's in the tube?
Oh. I was chilling and traveling from Germany all the way to here. One of my resellers in Germany, we were talking to him about a month ago. I'll bring you some. I'm coming to
Uh-huh. It's the same place, right? You must carry it. Oh,
So if it's converted,
well, that's a very nice thing to have, you know, waiting for you. If you're a gin fan, that is. Cool.
because he didn't mean me to say, oh, so.
Important that people drink gin. It's important.
I'm gonna get a guy who's proud of it.
All right.
Clint, I do see your desktop, just so you know.
you did.
I did, yeah.
You're seeing your entire desktop.
I know, that's why I'm trying to quit all these things. Everyone's seeing all my chat programs. Hopefully they're seeing my pretty pictures.
Yes. If you don't know, Clint takes a lot of beautiful photos.
Follow me on Flickr.
Yes. Have Flickr in the house.
Flickr is also one of my customers. From a perspective, I've been
how I have a flicker sticker on my laptop.
Flicker sticker. Flicker sticker. All right, we're running about 10 minutes behind, so
I'm ready to roll when you're ready to roll, Rachel.
you guys ready to go, or do you want to wait a few more minutes? Do you think more people are coming?
I'm expecting 15 new followers after tonight. So.
There you go.
Take a look. Let's first go around the room and see who's here, and then Clint can get started. All right.
I'll start. Eric, I'm still leading the group.
Eric needs help.
I need help. This might be the last one I come down to. I'll just probably do it remotely now. I drive all the way from Folsom to help Rachel out. So good to see you. I'll still come again eventually, but I just wanted to make sure there was a San Francisco Splunk user group. So
Yeah, it was kind of someone
seemed
said
appropriate, right?
that they were surprised that there weren't as many people at this one than that the Dallas one. So we got to be
Well, we're
better than
growing.
the Dallas
The
one.
first one we had 5 people.
Yeah.
So
This is looking good, guys.
we're doing better. So
I'm Rachel, by the way. I'm in charge of community. If you have any community questions, email me, rachel@splunk.com. Who's next? Start here.
I'm Philip, long-time sales Splunker.
I'm Irina with Splunk Marketing.
There we go. All right. How about that? Ooh, I love this.
That is pretty cool.
I'm gonna come in about 20 seconds to hear.
Okay.
We'll shift one.
All right. And I'm a Flickr user, as I mentioned. You can follow me. I'm Clint Sharp on Flickr. I'm still trying to figure out Flickr's Explore algorithm so that I can get more of my photos on the main page. I do get a number there. I will give free software for inside tips. One of my... you can actually use Hunk to. We have a blog post about how to use Hunk to analyze your photos. Not just EXIF. So Petter, who isn't here tonight, but I think may have come to one of the past, or maybe I should just recruit him to come by and show what he has done. But Petter built a record reader and preprocessor for Hunk that takes actual images, calculates the average color value of that image, and then allows you to search by color. For example, this would probably be largely black. This would possibly be somewhere between green and blue. So if I search for blue, it would likely turn around and look for sort of a nearest neighbor sort of thing. It's pretty cool. It's just an example of. Actually, we're here to talk a little bit about Hunk today anyway, and our archiving feature. Hunk does not require data be text. Hunk can analyze any data at rest in HDFS. Splunk, the engine, works on text, so we can look at any data and turn, as long as we can output some interesting information about that data in text format, then Splunk is perfectly capable of working on that data. So his example was not exactly practical. I mean, nobody really wants to analyze images with Splunk, but it goes to prove the point of maybe that data you want to look at is packet capture data, or maybe that data you want to look at is stored in some sort of more interesting format. For example, some companies like to use really weird ways of storing their data in binary log data, or perhaps you're a system D fan and you like to log data in binary. I don't know why you would want to do such things. BSD for the win. You might want to be able to analyze that data and translate that data to text on the fly. So Hunk gives you some of those capabilities. So let's talk a little bit about. So I was asked to come speak about the archiving feature. So Splunk, or Hunk, was released about 1.5 years ago at our users conference in 2013. Hunk is Splunk's search engine, role-based access controls, dashboarding, basically everything search language and above put to rest upon data that's not in Splunk. And so long about 2 years ago-ish, we started taking a look at our technology and said, man, love our search language, love those dashboards. Don't particularly care whether they stored the data in our index or not. That user interface, that query language could be put to use upon data anywhere, right? And so why not? So we began an experiment to essentially decouple the data storage from the rest of the product, and that bore Hunk, right? And Hunk is named for Hadoop and Splunk. It's a cute name. I like it. It's actually set the bar a little bit high in terms of product naming, and in fact, every other product we release now will be a disappointment relative to Hunk, because I just love the name so much. And so, although it is an incredibly polarizing name, there is no one who is mediocre on the name. You either love the name or you think it's absolutely retarded, or offensive in some cases. But I, in particular, happen to love the name. And so what Hunk does is, as I take and I want to write a search, it's a Splunk search. I don't know any difference from a user perspective whether I'm searching a Splunk index or whether I'm searching data in Hadoop. We go, and instead of making a bunch of TCP connections to our indexers and handling MapReduce essentially on our own and mapping this search out to all of our indexers and reducing all the results from our indexers, we instead simply spawn a process. This process is a helper process. This process takes that search and then does work. And that work could be, in the case of Hunk, dispatching a query to Hadoop. That worker process could be, go fetch me data from the file system. That worker process could be, open up a network socket and listen for data. We've done all sorts of really weird proof of concepts for what I can do with these results providers. But Hunk in particular dispatches a MapReduce job. And Splunk is a MapReduce-like architecture. So it was relatively easy to adapt the paradigm that we work under from the Splunk perspective, which is I have this concept of the search head, right? And I have the search head here that a user interacts with, and the search head then distributes a bunch of queries to a bunch of indexers, right? And that query runs and generates a bunch of data, and then we generate an interim set of results. And we then bring all those results back to the user tier. And one of the cool things we do is we give you previews for that data. So as soon as I hit enter, I start seeing data come back. No matter how much data I have underlying all this, we'll show you interactive results of that data. When we did this with Hadoop, we wanted to preserve that same sort of experience. But this is map and reduce, right? I'm essentially sending a map job out here, and I'm saying, go run some calculation out here in a distributed fashion, and then give me a much smaller pre-calculated result set, right? Bring me, it could actually be the entire result set, but in general, let's do some work out here, every one of these nodes, and go turn all this query into something that is a bit more useful to me. And then let's handle reduction up here. So in the case of Hunk, rather than do all this and come across to all these different indexers, what if all of those indexers, in fact, were handled by something in the middle called, like, in the case of Hadoop 1, a job tracker, right? In the case of Hadoop 2, this would be a yarn resource manager handling the yarn and MapReduce tasks. The job tracker then figures out and says, okay, you have this MapReduce job. I want to generate a mapper out to all of my task trackers. So this architecture looks an awful lot like our architecture. I send the job out to a guy who says, figure out how to distribute this work to a bunch of different worker nodes. And then eventually there's a reduction phase. In the traditional Hadoop world, this is done in Apache land. Like I take and I do multiple things. I may sort the data. I may shuffle the data. I may do various sort of primitives, or I may send that data back out for more work in additional map phases. In the case of Splunk, we handle reduction ourselves. So these task trackers out here write a bunch of interim results files to HDFS, which Hunk, from the search head perspective, picks up and displays to the user. So we've essentially taken that core of Splunk and said, I'm going to make it run inside of Hadoop. And inside of each one of these task trackers, we're literally running the exact same binary that we run here and that we ran on all of the indexers. From a user's perspective, I can actually dispatch a job over here in the same search to a set of indexers. And we'll dutifully combine the results from data from Hadoop and data from our indexers, and all of this sort of all works together seamlessly on behalf of the user. So we've been working on this for a couple of years. We've iterated on it. We've added support for additional data formats like Parquet and ORC and RC files and sequence files and all sorts of sort of very germane stuff for Hadoop. We've added a really nice acceleration feature where the nice thing that we've realized about data at rest in Hadoop is generally it's time series data that we're analyzing, just like it is in Splunk. Generally, once you write that time series data, it tends not to change, right? So that data, once written, if I run a particular map task against that data, and I run that exact same map task against that exact same data, we can generally predictably get the exact same results as we were going to get before. So what we've built is a feature that we call report acceleration. So we allow you to take a specific job that you're running against any of this set of data and accelerate that, which is essentially a cache. We're basically saying, hey, every time if you run this exact same thing over again, you can expect the exact same results. That's thankfully not insanity in this case. And we can dutifully reduce all that back and give you very, very fast performance for reporting. And then Hunk 6.2, the last little bit of innovation that we've added just recently, and we actually don't tell Kishore, who runs our maintenance thing, but we sort of squeezed out some new features in a maintenance release, right? Not supposed to do that. Bad. But we also didn't want to wait until our release that's going to come up in August to get this feature out to people. And what we've done is we've said, okay, inside of an enterprise, what we hear from many customers is I may pay something like, this data over here, I may pay something like $9 a gigabyte a year, right? So that's oftentimes indexers are put on SAN, they're put in a virtualized environment. Corporate policy dictates that all VMs must be placed on SAN and all VMs must be placed on Tier 1 storage, and the cost of Tier 1 storage is $9 a gigabyte a year. And so even though despite the fact that we offer clustering over here, we offer many of the same features that you would expect out of a Hadoop environment in terms of managing redundancy for your data, and we would recommend that you deploy on bare metal, we still find that the cost profile that we get back from customers is very, very expensive. Those same customers tell us that a lot of times they'll be offered an internal Hadoop service at something like 30 cents a gigabyte a year. That's a significant difference of 30 plus times cheaper, right? So if this data that's being stored here is, in general, Splunk Enterprise will provide you much better rare term search performance, right? So I will get a significantly faster needle in the haystack search out of Splunk Enterprise than I will get out of Hunk. But once I get past 7 days, 14 days, 30 days, how often am I really looking for needles in haystacks anymore? Not generally as much. I'm not generally going and looking for that very, very rare term search. For my older data, I'm doing generally a different profile. And we've done some research on what users generally tend to search. Something like 60 to 80% of all searches are run over data that's the last 4 hours worth of data. And so we know that this data that's old is significantly more infrequently accessed, right? So why am I paying $9 a gigabyte a year in my internal chargeback rates for data that I only look at every once in a while? We also know that people from a digital world tend to be pack rats, right? So they tend to like to keep data around for a long time. Sometimes this is because they like to, and sometimes this is because their regulators and auditors tell them they must, right? So in certain cases for banks in Europe, et cetera, they have regulatory requirements which mandate that they keep data online for 13 months, sometimes for 36 months. And they still want to be able to access that data for a very long period of time. Lastly, the other thing that you come to realize as you look at the profile of this data, if I'm not searching for needles in haystacks anymore, that inverted index that we build and maintain on your behalf starts to become a pretty significant storage cost, right? So the general rule of thumb about how much data you're going to use in Splunk is you take the raw data, right? So let's say that I have 100 gigabytes of raw data. I'm generally going to get, let's say, 10-to-1 compression-ish on this sort of data, right? So my journal or my raw data is going to be, let's say, 10 gigabytes. And then, as a rule of thumb, the inverted index is generally about double the size of your raw, right? So what we call our time series index or TSIDX files will then be about another 20 gigabytes. So 100 gigabytes of raw data ends up being 30 gigabytes on disk. These files are really, really good for helping you find needles in haystacks. But we just said before that the research we've done says I don't generally find needles in haystacks on data 30, 60, 90 days old anymore. So therefore, I'm actually storing nearly 3 times the amount of data that I really need to given the profile. I can still search this data. I'm just not going to be able to search it nearly as quickly without this inverted index. And so having heard this problem from customers, we decided that we wanted to go out and find a way to solve this problem. How can I lower the profile of this $9 a gigabyte a year, and how can I start to give people something that approximates more like this 30 cents a gigabyte a year while still offering them the exact same functionality from a user perspective, just possibly a different performance profile. And that's what we did in Hunk 621 when it came time to start offering this archiving feature. And so what we do is we take these buckets that are stored inside of these indexers, and then we move them on your behalf to HDFS. But we don't move this because that isn't really all that useful for you anymore. So not only am I storing a third of the data on your behalf, I'm generally storing it in some place that internally is much cheaper for you, right? The interesting thing about that is that there's really, if we want to talk just technology, and we're all technology folks in here, you can put this on the exact same thing as this and pay the exact same dollars a year in terms of how you provision your cluster, how we do data replication, etc. We just find that people don't. And so we can either recommend to you that you do it this way, right? Build our Splunk nodes on the same class of hardware you put on Hadoop, put us on bare metal, get that same cost profile. That's what I'd recommend you do. Then you won't have to do any of this archiving stuff. You won't have to maintain Hadoop. You won't have to do any of the rest of that. If you're not already a Hadoop shop, you could stand up Hadoop just for this use case. But you don't have to do that. You can do that over here as well. But we're also finding a lot of enterprises who have this available at their disposal. They're getting pingbacks from their Hadoop group that says, hey, I'll give you this, I've got this big Hadoop cluster with lots of storage available to you. Here's what your chargeback rate's going to look like if you come to me. Does that sound right? Is anybody else in the room hearing that inside of their groups? Anybody have Hadoop cluster? I mean, I know you guys have got massive amounts of Hadoop, so that's not even a question, just Yahoo have Hadoop. Yahoo has plenty of Hadoop. Yahoo has 600 petabytes of Hadoop across 35,000 plus nodes, so we know they've got to do. Other people? Other Hadoop clusters in the room? Yeah. Are you hearing similar things from sort of build back rate, or is that?
Ours is a little cheaper, original cost, cheaper for per gigabyte price. Big push for a lot of heavy data.
So more of an architecture determination, like the enterprise architects have said, this is the landing place for data. So
Data warehouse schema has been using for a long time. So now I think more of a distributed environment, but spaces are starting to say, we can. Before they didn't really have a need or a value to store a lot of operational data and whatnot. Now they're starting to use to store that data to look back and say, hey, what did Black Friday intervals look like, for the last 5 years, year on year? Whereas normally you would only have operational data maybe on server for up to 30 days. So having that data to look back and then build in things with Splunk to use like anomaly detection and things like, hey, what did it, yes, web traffic spiked on this day. That's not abnormal for the year, but then what did that look like versus last year, the year before, and then do comparison. So keeping the data and having it in a place where they can pull that from is got a value to it now. So yeah, there's a target for that data.
Awesome. I hear that a lot too. Certainly been hearing that quite a bit. Anybody else?
I was going to ask a different question. Regarding HDFS and Hadoop flavors, is there any restrictions on wiring up Punk?
No, we generally should work with anything that is it pretty much any version of HDFS, pretty much any version of Hadoop. We generally test on Cloudera, Hortonworks, and MapR. We're a sponsor of the Open Data Platform, which is emerging. That's a bit controversial. That's been fun to watch. All the Hadoop vendors are starting to get angry with one another, which is predictable and long time coming. But in general, we feel like less distributions and more standardization would be a good thing for everyone. Other questions or comments? The demo is incredibly unexciting. We will do it, but it's no. It's kind of funny. So this Scrum that I work with on the Hunk side, I have a number of products in my portfolio, but I tell them often that they're kind of boring because every time they tell me it's like time to use the feature, like I use the feature, it just works. There's generally no bugs, and it just is like. Like, well, I can't give you any feedback. Like, you already thought of everything. Like, it's there and it works, and cool. So, awesome. Well, let's get on with it then. So, inside of Hunk, we have a screen here called Virtual Indexes, and virtual indexes. This is why you should never allow engineering to name features because they will do it poorly. Virtual indexes aren't actual indexes at all. They're only called indexes because inside of Splunk, when I want to access something, I could say index equals foo or bar, which is kind of wrong because that's not actually the index. It just happens to be sort of the place on disk where we have stored things, and so therefore a virtual index is not an actual index at all. It's virtualized from the perspective of Splunk. So that means if I have a virtual index, the data exists outside of Splunk or elsewhere. And so in Hunk, if I want to configure data that I have access to, then I configure a virtual index. And so in order to configure archiving, I will have configured a provider. And if you've never seen Hunk before, I'll give the Hunk is also an incredibly boring demo as well, by the way, because when you're done, they're kind of like, well, this looks just like Splunk. And I'm like, yes, I win. This is exactly the point. So with Hunk, I've configured a provider. The provider has various things that I configure about it, like how do I get access to Java on the machine that Hunk is actually on? Where is the home of the Hadoop binary? So I need the Hadoop command line utilities to dispatch a MapReduce job. Just like if you've ever, anybody ever dispatched a run a MapReduce job by hand? Anybody in the room? Okay. It generally goes something like Hadoop jar space com dot something or org dot something space parameters. Well, we do all that on your behalf. We need the Hadoop command line utilities in order to dispatch a MapReduce job. We are dispatching a MapReduce job just like all of the rest of the world dispatches a MapReduce job. I need to know where happened to be that job tracker. Because I set up this demo environment like 2 years ago, we were still on Hadoop 1 and I just haven't changed it yet. So it says job tracker. If I select yarn, it will say resource manager and ask me for a couple of other things. We support Hadoop 1, we support Hadoop 2, MapReduce or yarn, either one is fine with us. And then I need to know where is the root of the file system. So where do I go to access HDFS? And then inside of HDFS, I need a working directory. Here I will store some files. This is where I will store interim results. This is where I will store my package that I use to distribute to all the task trackers or node managers. I can select specific job queues. I can configure Kerberos inside of the UI, so we do support Kerberos in terms of authentication. I have a checkbox here for enable pass-through authentication. This allows me to map Hunk users to Hadoop users. So if I have a set of Hunk users and I also have a set of users on the Hadoop side, then I can have users map from Hunk to Hadoop. So the jobs will actually be dispatched as them, and so thusly their HDFS permissions will carry through and their MapReduce permissions will carry through as well. Then I can configure in arbitrary numbers of parameters that I will pass through to Hadoop directly, or that may configure special things that we document for you on the side for how to do more advanced things in Hunk. The thing you will learn about Hadoop if you work with Hadoop is there are no shortage of the number of options of things you can tell it. You can tell it all sorts of things, like how much memory to use, how many mappers to use, how many reducers to use, and there are literally hundreds upon hundreds of options that I can specify for any given MapReduce job. Since I didn't want to have to plan in advance for all of those things, what they could be, we give you sort of this key value interface for being able to specify those additional things that we may not have thought of in advance. Then if I'm just looking for data inside the file system, I would configure a virtual index. So the virtual index in this case, I have a virtual index called Clint, and I have some data inside of my HDFS directory. But in this case, we're going to archive data, so we're going to do things slightly differently. In this case, we'll actually build a virtual index for you based off of configuring this archive. So I'll hit new just so you can see the workflow as we go through new. I can specify a number of indexes that I want to look at. And grab from. I can have multiple numbers of indexes I grab from than I store in. So I can actually select multiple indexes and collapse down to one. Generally, most people do it one-to-one just because we will create a virtual index called _archive that is generally a one-to-one map between the two, but you can select what you want. I select a provider that tells me where I want. I say where in HDFS do I want to archive that data, and then I select older than how many X days do I want to copy these buckets. So the way this works in this version, we'll add some other features in future versions, but the way this works in this version is as soon as the bucket moves from hot to warm, it is now eligible for archiving. And so our recommendation is that you do this on a very frequent basis. You select it, I probably wouldn't say seconds, but have it check every 60 minutes or every hour, etc. And keep a full copy of all of your data in Hadoop. Conceptually, people think about archiving like, I want to roll, when the data is going to roll out of Splunk, I want to then copy it over to Hadoop. We are eventually going to enable this as an option, but the reason why this is bad for you are a number of reasons. One is, while that data is in flight, you're going to get wonky results. Right? So we're going to grab all the data from the Splunk index here. Then there should be some data that's kind of in the ether while it's actually either in both places, worst case scenario. Well, actually, worst case scenario is either in both places or it's in no places. In which case you will have gaps in your data and weird results. So if you want to actually rely on those results, our recommendation is not to do things this way. But some people have a sort of moral objection to having that data in multiple places, right? So in this case, our recommendation would be to take and very quickly, when the data rolls to hot, to make a copy of that data to Hadoop and think of your archive index as the thing that has all the data, and think of your normal index as the thing that has the near-term data, and direct your users to search for rare-term search the data that's in the near-term data, and search the archive when they want to do more analytical queries. Eventually, we will also offer a feature probably in the next release that we're going to call Smart Search that will manage this on your behalf, and we will figure out which index you should be querying, and you'll just have one name that we manage the queries across both sides. That's not necessarily committed, but it's something we're looking to do. So once that's set up, and again, back to, hey, this shit's kind of boring. Like that, now it's done. Like that's it. The archive is there, right? And we will go and copy things on your behalf. Yes.
So you're not pointing to the frozen data?
No, we are copying data as soon as it moves from hot to warm. So back to the thing where you're just saying exactly what I was saying. Philosophically, people think, I want to do it when it moves to frozen. That is generally what we would recommend you not do, although we are going to build support for that in the next version.
When you specified the index, that's the index on the Splunk index.
Yes.
That's that name.
Yep.
And what about size restrictions? Like what if you foolishly set up indexers with almost everything's in name?
You'll end up with a bigger archive.
Are there going to be some kind of bottlenecks?
No, I mean, like for the most part, if you start doing maths on how much data there actually is and how much data there is to copy, it's actually really not all that much, right? So assuming I index on any given indexer, I'm really pushing the limit and I'm doing 1 terabyte a day on an indexer, and then I need to make a copy of that same data on the backside, it's already going to be compressed. We're only going to be copying the compressed files. So from a raw data perspective, you're copying 1/10 of the data already compressed out the backside. You're going to be using the outbound side of your NIC. Remember, I have a gigabit on the in and a gigabit on the out. The ingest side is the gigabit in. The copying out is on the egress side of the NIC, so it's a different set of capacity. And lastly, it's just really not that much data. When you start thinking of how much a gigabit is 125 megabytes per second over 24 hours a day, that's a whole lot of data that adds up to way more than 1 terabyte. Which is generally what you can index on a given indexer in any given day. So generally, no, you will probably not hit any sort of, the most you could do, you will not likely to hit capacity issues. But in the event that you do want to configure those things and you want to give some sort of governors to that, there are some parameters that we allow you to specify in terms of, I'm trying to remember where, enable archive bandwidth throttling. And so if you are concerned about such things and you do want to limit said things, we did think about that in advance, and thank you for reminding me. We do have a feature in here which allows it to limit it to X amount of bandwidth per second so that you won't end up starving your indexers of bandwidth. The time in which this will actually bite you is when you first turn on the feature. It's not when it becomes a steady state. It's when I enable it for the first time and I want to go copy off, several terabytes worth of data I have sitting in my index. Without that turned on, in theory, you could end up saturating your NIC, although it's probably more likely that the write side of Hadoop, being a fairly synchronous operation, will be slower than the push portion of our side. But that being said, sorry. So we digressed from your question that I wanted to get.
I do have another question. How do you deal with the duplication and the replicated buckets for cluster?
So we are cluster aware. So we know where the master buckets are, and we only copy the master buckets. So we know all the slices of all the data, and that's part of why people oftentimes go back and look at Petter's first cut at this, which was called Shuttle, which was an open source project. It is not cluster aware. Don't use Shuttle. Shuttle is bad. We probably should have pulled that project down some time ago because it really stopped working about shortly after 5. Right, exactly. When they went to work for Boris and Petter was the only one who stayed, we probably should have pulled that project down. But it is not cluster aware. This is cluster aware, and we also make guarantees that the data we copy is actually the data. Like we did a lot of testing to ensure that the data that comes out the backside is the right amount of data. But your point about like how do I the cluster aware side and the frozen side. The reason why we recommend you have an archive index that is nearest to real time as possible is so that conceptually in your user's mind you're directing the right queries to the right place. We also don't have facilities in Splunk. So Splunk is not a database. I should write that in big letters somewhere, like Splunk is not a database.
Tattoo.
What's that?
Tattoo.
Okay, all right.
Yeah.
So things like making sure all the numbers always add up all the time and are exactly right. Don't close your books on Splunk numbers. I mean, like that's not why we built the system. So we try as best as possible to make sure that we never lose data. We try as best as possible to make sure that when you run a query that you'll always get the same numbers. But we did not build the system to absolutely ensure that when you always run the query, sometimes you will get different numbers. If an indexer goes offline while the other indexer is coming back online, we will dutifully serve you that query with the wrong numbers, right? So same sort of thing goes with index archiving, and why we don't recommend that sort of cold to frozen sort of side, because we will dutifully run the search for you, and we will dutifully, if the data's in two places at once, we will dutifully give you both copies of that data, and so you'll end up with these weird blips in your data, and maybe you then take that data and output it and put it into some other system that's designed to actually make sure that all the numbers add up and you get the wrong numbers. So that's why we conceptually, we believe it is a much better thing to have an archive index that is the full copy of your data.
So what do we do with the false one? Nothing.
You put it to dev null where it belongs.
Where did you specify the indexer name?
I don't specify the indexer names.
How do you?
I know what searches. We distribute essentially a search, right? We know what all of our search peers are, and so when you run, there's basically a custom search command that gets generated, which is called. It used to be called role buckets. I think now it's called archive buckets or something like that. Anyway, it's a pipe archive or whatever. That will get distributed to every indexer that you can search, and we will then, through bundle replication, push out all of the bits required to do the archiving. And we know about such things, so we know about where all your indexers are.
How? Sorry, I'm not getting it. How does Hunk know about
Splunk? Because you will have configured that. So Hunk is a search head.
Oh, so you just put it under search heads, search peers, just like.
Yeah, just like you do Splunk. Yep, it's a search head.
So Hunk gets installed on your existing Splunk Enterprise search head?
Yeah, so on the list of things we screwed up really badly over the last couple of years was we decided we wanted to release Hunk separately from Enterprise. Well, I decided. And so we decided that it would be better to split out the package and have Hunk as a separate package, and then this idea that a Hunk search head was a superset of a Splunk Enterprise search head. That turned out to be really confusing, and everybody really didn't understand exactly where we were going. So we have a better together story. We're getting back together. Hunk and Splunk are getting back together in the next version, and so all the bits will be the same again. And you will turn things on via license key and off via license key, and all of the things will be the same again. So conceptually, you can think of Hunk as a search head, and Hunk is a superset of all of your Splunk Enterprise functionality. In the future, they will be back to being exactly the same thing again.
But it's licensed.
But it is licensed separately. Yep.
So like what about licenses? Is this like stuff with 500 megabytes to pay free, or is it?
Actually, interestingly enough, if you install a Hunk license, you will not get the 500 megabytes free license, and this actually came up recently with a customer in France who bought a license to Hunk but wanted to run Splunk on Splunk. And found he could not do so because he had no indexing capacity, and so I said, well, just give them the 500 megabyte license. They should have that already. And then people said, well, we can't do that because that's a corporate governance revenue recognition. I'm like, but they already, anyway, so it was a very frustrating corporate thing where we did eventually get them a license, like support just gave them a 500 megabyte license. It was endorsed, it was fine. I mandated in a whisper that they do so. So if that ends up happening to you, we'll fix it. But in general, most customers, vast majority of Hunk customers are also Splunk Enterprise customers, so they also have in their licenser indexing and Hunk search as well.
So pretty much, if you want to use Hunk alone, you won't get this 5 gigabytes free.
You don't. If you find you need it, I will fix it for you. There's only a couple of Hunk customers who are not Splunk Enterprise customers. It's actually reasonably rare. There was another question somewhere that I'm. No?
Do you need Hunk if you are just using 500 minutes per day?
Do I need, what's that?
Do you need Hunk if that's a good use case if you are just using a bunch of megs, not even gigs or terabytes per day?
So the use case, well, so I mean, the use cases for Hunk are, first use case, you have data in Hadoop already, and you want to analyze that data. That's use case number one. Use case number two would be you are an existing Splunk Enterprise customer, you have a Hadoop cluster somewhere else, you want to archive data. Use case number two, right? Beyond that, most of the other use cases are more kind of come down to ideology in terms of like someone's already decided, maybe they don't have data in Hadoop already, but they've decided architecturally that that's where all the data is going to land, and so they end up bringing up Hunk with their Hadoop cluster at the same time. But that's kind of the positioning. In general, Hunk will provide you better dense searching for now until the next version of Splunk Enterprise, when we'll probably get them back towards parity again. And Splunk Enterprise will always provide you better needle in a haystack search performance until sometime in the future when we may fix that. And then it'll get really confusing. But for now, Splunk Enterprise, rare term search, Splunk Enterprise I would consider to be the superset product, like it has all of the things. And Hunk being the product where you have data somewhere else, you want to be able to use the same interface by Hunk.
With Splunk, you also pretty much can push data to Splunk using some different ways to do this.
Yes.
Potentially, you can put data in Hadoop, whatever, and you can still kind of push Splunk.
There's an app called Hadoop Connect, which will allow you to bring data out of HDFS and make a copy of it into the Splunk index. If you want to analyze the data in place, that's when you need Hunk. Yep.
Are you indexing that data at that time?
No. So Hunk analyzes the data in place. All index time processing is handled at search time, and we are analyzing the data in place. Thusly, why you don't get great rare term search performance.
But if you're bringing it into Splunk index.
That is with Hadoop Connect. That is an app for Splunk Enterprise, whereby which I'm making a copy of the data out of HDFS and bringing it into Splunk. There are use cases where. Yes, in that use case, yes. If I'm using Hadoop Connect to index the data, I'm grabbing the data out of HDFS. I'm indexing the data just like I'm indexing it from somewhere else. That's reasonably rare. There are still some customers who choose to do it that way. We still have that app for that reason, but it's not incredibly popular.
But you already mentioned it. What's the pricing model for Hunk?
Hunk is priced by the number of nodes in your Hadoop cluster. And it is very reasonably priced, and I think everyone would love it. Buy it now.
I'm just wondering, so when you're
I have a quota.
calculation of the index data on the $9 a year gigabyte, you have to factor that.
Sure.
If you are having that.
Sure. We had some sort of calculator stuff that we were doing on our side. The software costs become relatively negligible when you start, thinking about I'm paying. Some of these customers are literally on a Splunk install that's in the terabytes a day. They're spending millions of dollars a year in storage, right? And the Splunk software was a fraction of that millions of dollars a year, like on the side. Like they're paying a fraction of in Splunk what they're paying just to keep the data around. And I never did actually show you searching the data. Searching the data looks like index equals OI demo archive. And we will dutifully go out and grab the data. In this case, I'm streaming the data out of HDFS. Maybe I want to do something like stats count.
Where do you
Aha! Proving my point for me.
Repeat that. Just
Yeah,
we have
repeat it.
people streaming, so they can.
Yeah, sure. So the question was, where do I see Hunk? You don't. It is Splunk.
Boring demo.
What's that?
What a boring demo.
Exactly. See? Yes. What a
No,
boring.
there's a login. The login.
So I have both licenses in this instance. So if you have both licenses, it doesn't show you Hunk branding. It just shows you company branding. And so I don't actually have a demo environment, I don't think, which says Hunk anywhere, unfortunately.
Maybe House of Demos.
House of Demos might. I could check. Let's see. Let's see if there's a... There's probably a thing that says Hunk in here somewhere. Let's see. Hunk demo. Okay, let's see. Oh, that one doesn't say Hunk either. Dang it. Fail. Sorry, I don't have an instance that says Hunk anywhere.
Just a JPEG.
It is literally the only thing that we change when you are a Hunk only customer is on the login page, instead of Splunk Enterprise, it says Hunk. And on this page, right over here, it says Hunk. That's it.
Sort of like saying, "Show me Hadoop."
Yeah. Well,
No,
interesting.
It's, like, it's just there. Like
Interestingly enough, like let me find the job inspector. Let's see, search log. Oh, there we go. There's Hadoop. Right? I mean, like this is a hunk search being run in Hadoop. It created 36 map jobs. They're already done. My search is done. I counted up all the events. Right? I mean, it turns out to not be all that interesting. It just is. It works. Back to the point. They finished the feature and it worked, and I'm like, oh, I can't show this. This is boring.
It looks like fun.
All right. Any other questions? I know lots of things. If you have any other like product-y questions, happy to answer. Yes. I'm not entirely sure I'm actually going, for the reasons why I keep telling you why that feature is dangerous. I'm giving it, the cloud people are doing it. I'm not entirely sure I'm going to release it yet. I'd be happy to talk to you offline about all of the caveats associated with that. Again, I strongly recommend not doing it that way. Very strongly recommend not doing it that way.
So our use case is actually running Splunk in AWS on IT instances. But we want which have so we want to get that data off of those instances on S3 and
I would recommend, because for various reasons, doing it the way as implemented, which is when it rolls to hot, make a copy, have an archive index that contains the entirety of that data set. That would be my recommendation.
But that's going to get us past the storage.
Sure, it does. You would have an entire copy of the data in S3. We just, through the exact same process. We are archiving the data as it moves to hot. We're making a copy of that data on your behalf to any Hadoop compatible file system. Yes, that's what I just showed. We are managing that data on your behalf. We are making that copy. S3 is a Hadoop compatible file system, so you can use S3, absolutely. Yep, so when I say archive, when that bucket moves from hot to warm, I make a copy for you. And it goes to any Hadoop compatible file system. And when I search that archive, when I say index equals oidemo_archive, I'm now using MapReduce to hit a Hadoop compatible file system on the back end with the journal GC that was in the indexer, now in the other file system. Yes.
You've already implemented it. What do you want?
No. Yes, I built it. I built exactly what you wanted. I'm just not doing it exactly on the schedule in which you're asking for it. Which is, again, I'm asking for people to think of the concept slightly differently. It should not be cold to frozen for all of the reasons around how you should think about that data and how you should query that data. We make the copy for you. We have re-implemented Shuttle in a way that works, that is actually supportable. It is inside the product. But I don't do it as part of the cold to frozen process. I do it as an entirely different thing.
But it's not sexy, so.
Yep.
Cleanup work. So like you just keep dumping into the validation. Right? It's up to you.
Step 1, collect underpants. Step 2, Step 3, profit. Step 2, I don't know. That's entirely up to you. I mean, in general, I'd recommend writing some shell scripts with, remove files older than. We put it in a directory structure that is easily with Unix epic timestamps, that it's easy to see how old the data is, so you can go and delete old data if you so choose. But we don't handle the data management past where we do. We make the copies. We don't clean up for you.
There is no frozen bucket for the archive data. It's already.
It's frozen.
It's frozen.
We don't thaw it. We in fact we don't. We do not build the. It's different from Shuttle in the fact that we never built the bring back functionality. The goal is not to bring the data back to Splunk. The goal is to search the data where we copied it to.
just cutting holes to pull the ice out and do the research.
You don't need to defrost.
Yep. Yeah, it's very core sampling. Yes.
What size chunks do you do? Like if they're bigger, if they're too big?
So the size files that this is not a splittable file format. So Journal GZ is not a splittable file format. So our recommendation, if you want more splits, is to create smaller size buckets. In general, most buckets average, we'd recommend like 500 megabyte-ish size buckets, and that's a pretty reasonable split.
How do you prevent users searching for Splunk indexes to search into those archive indexes when they run every single query, any other query? So if they are running like as you said, 60 to 80% of the queries are for the last 4 hours, and they run the same query, they're gonna search also in these indexes, right?
Not automatically. We haven't built that feature yet, so that's why the index is named like index_archive, and you can define security for both. The reason why we didn't build it that way yet is because we don't really know how to do that management just yet. We didn't have time to build those sorts of features where we give you some type of control about, hey, I selected all time, so not only do I dispatch a search to Splunk, but I also dispatch a search to Hadoop every time the user hits enter. We got to do some thinking about that. That's part of what we're still working on.
So to search, to query into those particular indexes, you have to specify the index as an archive index, as you said here.
Yep. Yep. Right now, the user makes the determination whether to search the near-term data or the long-term data. And index equals this or index equals that.
Would that cause duplication?
What's that?
Would you do that union between the two indexes, rolling it as soon as it rolls, it's going into the Hadoop? Is that data still going to be available on the cluster, the enterprise cluster, and the Hadoop at the same time? So if you do index equal archive or index equal my local, give me everything. Am I going to get data?
Yep. Okay.
Just making sure.
Yep. Back to that. Back to that. Things we must figure out for you eventually at some point. And why we didn't do it transparently just yet. Yep.
So how's the journal handling? So you're rolling this data over to and you've got Splunk Enterprise with I don't know, something like Apache log. In order to keep your Apache log for this particular instance, Splunk.com forever, you want to know every traffic hit, every game. But data over a month old, you want to know the journal. Splunk for Enterprise is monitoring that bucket for that Apache data. How does that transfer with it whenever you're rolling the data that the journal doesn't roll?
The journal rolls. We're rolling the journal.
But every 60 minutes instead of every month. Right? You are running.
No, I mean the journal is all the data. So whatever data was in that index, that is the journal. So index equals foo, all data that was in that index will be in the journal, and all that data will move when you archive that index.
Are you constantly taking part of the index and moving it over there?
No, we move it when it moves from hot to warm. It's not available until it moves to warm. That means the bucket is cold. That means the bucket is closed and is no longer being written.
And how do you close I forget this part. How do you close the bucket and then end it?
The bucket moving from hot to warm is configurable based off of max size or max time.
And then a new bucket with the same name is created?
No, a new bucket. Hold on. Let me show you a bucket. Sorry. Oh, pooey you. Ah. All right, so let's just go to underscore internal. I go into DB. all these things DB underscore, these are all buckets, right? DB underscore, this timestamp, DB underscore 1, 2, 4, 3, 3, da, 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 where am I at? 1, 2, 3, 4, 3, 8, 5, 7, 8, 9, 5. All right. So these two timestamps here is from when the bucket started to when the bucket closed. So warm is in a different directory. Warm is in hot. You see hot v17. That is where data is currently being written. As soon as the bucket moves to warm, it is no longer hot. It is now all the data in there. We stop writing to hot. We create a new folder that says db underscore this. These folders contain various information. One of these is journal GZ or raw data. Others include various data files which contain data about which source types have been written, which sources have been written. There's a slices.dat. There's a variety of data in the bucket. But I mean, I encourage you to come. There's documentation for this online, etc. You can go look and see what various things are in the bucket. But it is a bit esoteric. We don't do a very good job of telling you exactly what all those are. But that is what a bucket is. Unix epic.
What time format is the seconds?
No, it's microseconds.
Microseconds from specific date.
From January 1st, 1970.
Okay, and what's underscore 2 is like
I'm not entirely sure, actually. It's in the doc somewhere. I don't know exactly.
Yeah, if you look for understanding buckets or something, I think there's also a wiki topic about it. It's pretty detailed. There's a question from IRC, from Ed Langer. He says, why archive to Hadoop at hot to warm when you mentioned that the needle search on Hadoop isn't as good?
You archive when hot goes to warm because you want all of your data there. So if I want to run a dense search against the data, Hadoop's going to be now my copy of all the data. I want you to think of Hadoop as the copy of all of the data. It has all of the data since you ever started archiving, right? And so if I'm going to do a dense query against all of that data, let's run the dense query against the thing that has all the data. And so that's why I ask people to think of things very differently. And if I'm going to say index equals foo pipe time chart average this with no search parameters with everything, if I'm doing that type of query, that query is better off in Hadoop. That's why we do it then, so that you can have a recent a very, very close to recent copy of all of that data somewhere.
So how long do you recommend to keep the recent data in the expensive bucket, the hot and warm?
It all totally depends, man. Like, what's your requirements? For some customers, that's 7 days. For some customers, that's 90 days. For some customers, that's 30 days. For some customers, it depends on the class of data. They may want, for security use cases, they may go back 90 days and do really needle in a haystack searches, right?
In that case, if for compliance, they need 90 days. Those 90 days are already in the Hadoop cluster. So for compliance or for whatever regulatory reason.
Not usually, actually. I mean, getting data to Hadoop's not nearly as simple as you think it is. A lot of times it's not there. So this for many people, this is how they're going to end up getting the data to Hadoop. But if it's already there, then in which case you don't need this feature. You can just search the data from Hunk as we sold Hunk to begin with.
Yeah, so you have the same data in Hunk as well, right?
If you have delivered the data via a separate channel to Hadoop, then you just use Hunk to search the data. You don't need to archive the data to Splunk. Cool. Thanks, guys.
Let me know when I go. Usually if I do it.
Yeah, they are. Well, because there's so many more.
I guess, yeah. Stuff.
That's almost Texas orange.
So.
Walking trucks and I live in Dripping Springs. Oh yeah, I lived out on 180.
That's right. Round Rock is like Wisconsin. It's that far away from Dripping Springs.
It is truly.
Yeah, it's practically Wisconsin. All right. I'm Michael Wilde. You know, we're all still here.
We're all still here.
Yeah, who did you go to work for?
I'd have to look
Lucid Works, I think, where Will Hayes is at. Yeah.
Yeah, me and him went to high school together.
Oh, you and Lutz?
Yeah.
That's great. All right.
It's all connected.
It's all a series. All right. All right, what do I do? I guess. And then screen share. Oh, look at that. That's awesome. You see that? Oh, is it, maybe the projector went in sleep mode, maybe? A chance. Oh. $480. Hey, that's better. I like that. Hey, there's me. Awesome. All right. Now let me change back to this guy here. So shut the green. This guy? That guy. Right there. That one. The screen share one. Entire screen, right? Oh, I clicked that before. Maybe it failed. Now it.
Low battery.
Now it's meta. That's not, well, I can fix the low battery problem. Hangout people see this? Okay, good. Let's switch off of it. There we go. All right. All right. So and You want to try again? Entire screen?
Yeah, I gotta.
What I was saying earlier.
Yeah.
A lot of Splunk people
Yeah, I was just telling her the way we did it in Dallas was we had a mailing list that we would send in, kind of use it as our out of meeting. Down the bottom, you got on. Yeah, meeting.
All right.
Same work for us. Catch up going.
Yeah,
So we have.
would you join a mailing list if I set one up? Just a regular email mailing list?
I'm just trying to get something to display.
I think there's a lab.
Okay, you got back of the head?
Alright, it's fine if the screen is a little slow. Alright, let's get going.
Okay, good. Yeah, awesome. To talk to you about Splunk. Right, and without any idea what to talk about, at all, any questions you want to ask that you didn't ask Clint, because I'm not the hunk expert. The index question or I would like to inform the down and I would like to time and focus scholars. I found that especially what research and people want to use, however, when I put in the form, go down, it's sounds like this is special type of the form. But diagnosing a problem is probably not a bad idea. Sure. Right? The user group is supposed to do them. It's really easy for us to. Sometimes it's kind of boring, but I mean, for y'all, it's educational. But sometimes you have things you'd really like to talk about, and we could do that. But you know, you might be new with Splunk or need a different perspective. So I can show you some cool stuff. So I work, like I said, I've been here for a long time. You can consider the chief of awesome. Have a lot of product experience. I also work in a part of in an effort that show you today that like I particularly like and maybe you will find of interest or not. So first, here's sort of a pitch for Splunk for Good. Splunk for Good is non-data things. So, you know, we have not-for-profit licenses of our product, and, you know, we raise money, autism, and other things like that. Some that fell out. Oh, I lost my power. I lost my power. Thanks. I got it. An example would be related to social data. And an example recently was there was a mudslide in one of the big concerns disaster relief is fraud, right? Because bad actors will attempt to raise funds. You know, everyone's raising funds for donate. Track money, right? Also, police, sheriff, the law enforcement agencies basically asked us, hey, could you help us look through social media around the following 2-week period? Let's take a look at what shared, do some analysis, and then we, the authorities, will go and see if they're thing project we did. And some of those ways where we can use open, publicly accessible data to then solve an issue. The people who work here. Couldn't get involved with what we're doing, and we're good at Splunk, and you like building stuff related to Splunk. There is a job in the Splunk for Good team, which is kind of cool because most of it's been a bunch of us just using our spare time working on this. But we've done other cool projects. One of the other cool ones lately. So the federal government's, that wasn't a judgment, the word regime, but the regulatory regime, FCC and the EPA and all these regulations make rules right. They'll write up the citizen can write a letter. We can, you know, get out our typewriter off the top shelf and find the ink, write a letter. Not too many people do that nowadays. Usually they fill out forms. Of the comments to see if people are what the sentiment of the group. Okay, so the FCC, as you may or may not know, probably many reasons why they do that. But most of the other organizations do. So we got together with the EPA, which runs this website called regulations.gov. And they've got a public data portal, APIs that you can access. So what they asked us is, help us, you know, maybe way to evaluate all the comments. So we said, yeah. So me and a friend of mine, David Carasso, who recently passed away, first engineer at Splunk, got together. Script which goes every night and hits the API that the federal government has for all of regulations.gov. It's not a real-time streaming API. I wish it was, because then we wouldn't have to out to us, and that would be great. I'll show you another example where streaming is really from today. Put them in a Splunk index. Yay. We put together a bunch of dashboards. Now, if you were to go to splunkforgood.com, again, right? You go to another project, you're just logged in as well, right? You don't have administrator as a reverse proxy and using subdomains. So you can see the e-regulations on the server, then sends e-regulations in the HTTP header parameters to Splunk. Splunk then trusts this web server projects on one Splunk server and access. That's a little bit of background on how we could have had a public-facing thing that you didn't have to log. But of course, if you user and went to another app, it should say something like, sorry, you don't have access to that, right? Actually, I need to lock down a couple of those other ones so you can't even see it. But what we've done here is basically provided a portal where you there's 1.5 million comments over this particular period. There's broken parts about their API. To try to resolve that. But we also use Splunk's custom form creation stuff here. So, you know, it's nice to have a pie chart because everybody loves pie charts. So we see also, I don't, show of hands, does anybody use data models? They are. You ever heard of them? Okay. All right. Not probably investigated them. Went, I don't know what that is. Right. Right. So I'm going to use some the really nerdy people use TS. Okay. Good. All right. T-stats. Okay. Right. Indexing format. So one of the things that I cannot have happen on this particular server is I can't hit an index, ever. Because of the amount of searches that run on here and the amount of users that run on here, I can't be unzipping any, be doing any field extraction. It's just, this is actually one machine. What you call it, quota issues, right? For all of these, and it's a requirement of anything we do for Splunk for Good, is to use data models and to have them accelerated. The data model technology really is sort of, what, you know, when you do type ahead and you do the search interface and you're like, ERR, boom, that whole lexicon, that whole indexing format, it turns out it's all okay. So the data model process, when you make a data model, and then that's how pivot kind of works. To decide to save it. A data model, you describe and put constraints and do all this other cool stuff. Accelerated. So in data model, when you click accelerate, it's plucking key value pairs out of the main index via search and then dropping them and making your own custom build. Because every time you build any kind of data, you're kind of doing that when building a data model. But the fact that you can quickly click a couple of buttons, have your own pile of data, use it, accelerate it, and then throw it away, I mean, why we use that is because it's extremely fast, right? So when this page loads, or if you look at some of the other ones, like tweets for FEMA actually health during Hurricane Sandy. That was part of the project we had, and it's like 7 million tweets. And I searched on the word scared, and I time charted it. It was like the wickedest thing ever, because like we look at Splunk, and there's nothing but machine data, right? There's no emotion in Splunk's data. You type in the word scared, and they were describing to us, describing to us like what we should do. Typing scared, and all of a sudden, and it's like I got chills. I was like, "Whoa, this is weird." But you see, search index, okay? It's because it's hitting an here, so it's hitting the TSIDX format. But that being aside, it's kind of a fun thing. Odd to say that, but like our job is to help you use Splunk. Now, our IT group has a badass deployment of Splunk. Our cloud group has a badass one. Where like the amount of Splunk, like Fox, and on these vendors to give us data, like to open up the data on what our employees are doing so that we can put it into our product, we can analyze it, because most people don't create reporting until customers beg them, right? Good for the world, but it gives us a chance to see how the best ways to optimize it. I mean, y'all might not have users that would hit your Splunk server as but they did when we did a press release and FEMA did a whole thing. So we have this like big spike, and we did the same thing for we building it because it's a little janky, and this one's still on Splunk 5.0 because once something's up, you can't just redo. And this is actually using the raw index. But this was kind of cool. We downloaded all the FEC's data, put it in here, you know, and then made it so you could kind of follow the money. And this was for the last election in, what, 2012 when we did this. But it was sort of cool being able to use, when I talk about Splunk, you know, we did a lot of competitive things. A ridiculously intense amount of time making a composable web interface. Because like most of the time you create a dashboarding system and hey, you got a pie chart. Compose and develop with a bunch of controls and some XML, pretty cool user interface. Campaign Contribution Explorer, and you know, type in an employer like Google, jobs, and all of this other stuff, and this is all publicly. Ford gave us a couple of cars for a day, and we downloaded data from that and did some comparative analysis on electric car driving versus gas car driving, and it was completely unrealistic because everybody drove the cars like they were race cars, right? So like some, it's funny because some of the gas-powered cars, the speed that they were driving is 2 miles an hour. They drove 2 miles. The maximum speed in that 2 miles was 64 miles an hour. Yeah, you could tell from the video, and then somewhere over here, there's, I don't know if it's the compare. But somewhere on here, there's a map, and data was all coming right off of Ford's. So I figured it was a fun project. But you run infrastructures that are customer-facing, possibly. Okay. Right. So social data is accessible by two main places. And the other one from DataSift, who re-syndicated the publicly available Twitter data is useless, right? But it uses the 1% Twitter feed. Great data feed if you're a developer making a I actually want to see name, page, or whatever. So, and then the other thing is Twitter, especially Twitter, charges a licensing fee for their data. Matter of fact, you know, it's sort of like the stock quotes. You can get like 10 stock quotes on feed. You got to buy the market data. That's how social data actually really is. Now, most social data services, you can't take. But it's kind of cool that DataSift and this is kind of cool. I'm going to log in here, and DataSift basically has, you know, a big pile of data sources, and you know, I have a lot, and each data source has a license. Enriched with sentiment, topic, entity extraction, a bunch of other things. They actually do a really cool link analysis. So if you share a link, let's say you're a real estate company and your realtors share links on Twitter, you can go scoop those up. And the HTTP status code, which is kind of cool. You actually could add links. It's just an interesting perspective. But it's kind of a really great, let's say, interface. Okay, so this DataSift is basic. DataSift and so you can push data into all these destinations, and you can push it directly into Splunk, and apparently into Splunk Storm as well. Although that was the first thing they did, which is kind of nice. Less work for you to do. Click over to streams, and I can create a quick stream. I'm just going to say test. And you'll get an idea of sources. And these are just all the ones that I've currently decided, right? So I could just pick Twitter, but I also could pick all, which is kind of nice. I could just search the entire of all the data sources. You know, in some sort of radius, we'll just put it like a radius of North America. Okay. $1 million. But yeah, I might just create a new filter real quick and say where the content has the filtering technology in here, regex, and words that are near. Because ultimately, let's just say Bieber. Israel is also a pretty popular term right now. And I'll hit save and preview. Now, what's kind of cool is I can click here and it'll load these rules right into DataSift's engine right now temporarily. And if I hit play, we'll probably end up Justin Bieber. Of course, whenever you yeah, we can always assume that there's a good, but let's stop this guy. Well, the thing is, actually live, so if I'm looking for something that doesn't exist, the demo isn't that exciting. So it's a quick close. You and hit, yeah, Beaver's actually over. Okay, so that's coming. This is coming right off of Twitter. So boom, the minute it hits Twitter, boom, and the live feed will let you get an idea if the things that you're looking the cost. But this is kind of nice. I press pause for language, so they're doing some enrichment there. And then if I click on the bug, we can see this is a nice, they've created in Facebook, the and then this is a nice structured object, right? Their cloud score, maybe there's a sentiment. What do we got here? We got a sentiment. They're just doing 0 sentiment, right? And there's a high confidence. And which is pretty good. The reason why I said, do you run production services that are customer facing? Thing to consider, because you know, if you go into like I have a stream going most error, like website is down, and it's kind of interesting when you look at it, because if we just go to index equals social data, I just named the server social Splunk, we start to see interesting stuff. I'll just put the table view here. And what do we got here? We got data from a bunch of, and this is just from the sort of, you know, the bad opinions about your website, right? So there's data coming from a whole bunch of different sources, Twitter, Tumblr, message boards, there's Wikipedia edits. We could go pull off, you know, the things that are probably interesting are mentions, which is going to be like a retweet, your username, because mentions, let's type this right, mentions. Yeah. Data.twitter.mentions, that's probably good. Data.interaction.mentions is there. If we just open this up. So this is an example of, these are the websites and or people that are being mentioned on the social feed that describes website sucks, site is down, site is error 50, whatever. So because Splunk's this cool time series engine, if you were actually capturing the social feed on your brand, you might be able to see the tweets happen in some relative time of some infrastructure issue. Maybe? Possibly. That's, I think adding external data sources in is pretty cool. Any questions? I have one more cool thing to show you. Okay. Anybody heard of Octoblue? Octoblue is the thing that I'm most obsessed with. Any Internet of Thingsy / any nobody. A Nest. It's in my house. Belkin makes these, like, they're $50, and you plug them in, and they're internet connected, and of course, they got an app. This app here. I made a video of this so you can watch this later. And we can I play this on there? Yeah, not on the same network. Their little app that like shows me the back landscape. Lachlan ceiling, Lachlan fan lights. It is 10:30 in Austin, and I know he's not in his room. Okay, so the child has left his lights on. Now, I thought I had rules. I think I disabled the rules. But it's kind of nice because, you know, hey, we can turn off the landscape lighting. Woo. Great. But the one thing, like the orchestration is the hardest part of any sort of things that go on, right? So you might get into a world, like the things that I want to start to do is install a bunch of motion detect the direction at which you're moving through a hallway. So if you're moving out of the room, I should turn the lights off, and if you're moving into the room, I should turn them on. If I'm coming at the house, then maybe the other things should happen. And a lot of, up until OctoBlue came along on their own, okay? OctoBlue is this little company that turns out recently got acquired by Citrix, which is also cool. Because, you know, one of the world's small companies. And when you get help like that, that's cool. So, and these OctoBlue guys are also Splunk guys. So they're a customer, and they put a whole lot of data in Splunk. So if I go over and log into my OctoBlue account, we'll just log in here. It's a pretty cool system, and I guess the best way to describe it is like an orchestration. Spotify thing. So this is, oh, look, there's a Splunk there. Let's go over here. I'm going to say connect. So you can add. I have a Facebook account. You possibly do. I have a garage door opener. I have a that's called a gate blue, and that's actually going to talk to any devices inside my house. And so OctoBlue guys are building all this and that, but like you can orchestrate some really cool stuff. So, you know, they came for a while. So I started monkeying around it out. I couldn't figure out completely. And then, you know, they've got this nice chat box here. And they helped me, which was cool. We shouldn't have this in our product, but then, you know, that might be. Yeah, well, right. It's called Iron.
That little chat window slowly opening.
So this is kind of cool. If we see, I have a couple of devices here. Not available nodes. Let's go generator nodes or operator nodes. So I can make decisions here. Have a delay, multiplex, make a function, do comparisons, actually have a trigger, do a whole bunch of little basic options, kind of like, you know, the Splunk search language. You were taking these primitives and putting them together. And in this case, I'm doing it visually. So I created one button here that says it's landscape on, and it's really doing nothing. Now, the Belkin API is a little janky. So the button actually doesn't make the Belkin API turn. It doesn't make the Belkin device turn on. We had to make a little payload that gets passed forward because this is a little Boolean, and that's cool. And so now what's kind of nice is I can press a button, and actually both of these, you see this arrow is being sent to both. Both these devices are now being turned on. And probably the landscape at my house is probably on. Right. Back landscape and front landscape, right? And we can turn the landscape off. That's kind of cool. I think it's cool because I was able to take multiple devices in my house and automate them together. I did the same thing, and a lot of this was starting to test it out. The living room lights, I have a couple of them there. I have one on the living room lamps and one on the buffet lamps, right? Just like they're sitting there. Because I have this problem that people don't turn the lights off. I forget to turn the lights off. and all of that. And you could imagine a whole bunch of other scenarios. Now, so what I'm trying to do, and I just started today, is I want to take all these messages that are coming through and then pass them into Splunk. Because they built the Splunk connector in here, which is kind of cool, and then they implemented like almost every API wasn't doing inner things. One could probably use this to be able to do some fairly sophisticated orchestration. The alerting mechanism in Splunk could do. But I thought this was pretty cool. Matter of fact, from what I understand, almost everything that happens in all of these at our user. Just so you know, I don't actually have to. Mobile apps. One that can be used to tell where I'm at, so that I can have a simple screen which has all of my little flow actions here. So here we go. And pretty quickly. Should expect to see soon after to send events is push everything that happens from there. So, well, the home automation stuff or Internet of Things is I don't know. Probably. So, yeah. Well, let's. Does it say Git? Yeah. Right, so.
Start brewing coffee.
Yeah. There we go. Right. It's the we're nerds, right? I don't know. Well, I don't know the extent. I don't think the entire back end of OctoBlue runs on Splunk because this is a state machine, right? It's yeah. From what OctoBlue presented at our user conference, and if you Google, you can see the talk. Their analysis on what their whole entire platform is doing, every single action that's being taken. I think that's mostly what they're doing. And then naturally, they opened it up so that almost every API analytics on it. But to answer the GitHub question, what happens when we the endpoints, compare two commits, create a pull request. It looks like of endpoints, and so I think you probably could make a yeah, I connected to toilet. I'm just not there yet. Like I want to keep it old school. Yeah, and it's Belkin that makes that crop. Well, we should
case,
Have you ever used? Yeah, and that's what I'm hoping. You know, I'm and I have Wink. So Wink is this little thing you can get at Home Depot now, made by GE and Quirky, and it's like a hub, and it works with Z-Wave, which is a wireless mesh technology in home. One of these home automation platforms, and I'm like, it's either closed or it doesn't support this freaking device. Okay, so I've got a bunch of platforms, and then I hear about Octoblu, like integrating with Wemo and Wink and this and that, and like if this and that, if you've ever seen that, but letting me get at everything, but more importantly, letting it orchestrate in Belkin's app. I cannot turn a whole room off. Seems like an obvious feature that should exist. I should be able to turn all lights in the house. 2 hours to figure out how to do this because Octoblu's kind of new. There's a limited amount of documentation, and no one quite understood how they well. Me and a couple of guys, the founders from Octoblu, working together. You know, chat. A couple of minutes, you can drag a couple of things, put things in, and be automating and orchestrating things in your house or somewhere, right? Because this doesn't have to be your house. It could be many of the other, you know, you make just being able to take right. Sure. Right. So there's a lot of little cool play. You know, you do the blink. You listen. Those are just sort of random things that I'm involved in and I work on, and you go shell. There you go, right there, shell command. So that's kind of fun, and Splunk for Good is a cool effort if you're interested in is a city or a county or people that come to us. But the whole goal is, hey, our work should be publicly accessible so that people can use and benefit from it, see what it's like, and also you can point at that and say, look, I did that. People know what Splunk is, you can show them that. So, anyways. Outside, but outside, second side is we're over here. So like right here. Like data set. Oh, like how I'm doing the. Oh, it's so that on The reason why we have multiple, the reason idea to have links for people to click on. Okay, so we originally didn't start out with this website. Originally, it kind of started out as a trust business, right? And we had to give the press somewhere for people to click, so that they could see whatever the hell it was we were doing, right? And then shortly thereafter it became, well, if we're going to do a bunch of projects, we'll probably should have a website that shows what the projects are, but if I click on these, I need to make sure that when you click on them, they get to the right destination, right? Also, they're single-purpose projects. So if I use one username and password, partly analytics is kind of nice, because if I have a different user for each one of these projects, I can do at least some different kind of analytics. But I really don't want you doing anything other than looking at Hurricane Sandy when you have Hurricane Sandy. I don't want you going into the product. I'm getting rid of the menu. You're not allowed to browse around and do anything else. Okay? So, and I couldn't have a username and password pop up. Okay? Because that's not like putting analytics behind, public analytics behind a password would just be a right. What?
It would be governmental.
You'd go governmental. Okay. So basically, we looked at some ideas, and actually doing a reverse proxy seemed to be the easiest way to go, because by controlling the URL by detecting the URL as it comes in, and based on how the user, you click on Instagram. I'm now Sandy. It's basically the only way you can log into that, other than having the alternate URL that our team uses. Doing it with subdomains was kind of slash this slash that hyphen pipe. I can actually give out that URL, but at the same time, I'd really love them to tweet that. I'd really love them to take that person that clicks on that gets there. Does it answer your question? Oh, here? Here?
Social Splunk kind of.
Oh, that's just my own Splunk web server. Yeah, social Splunk data statistics out there publicly. I mean, that's kind of what we do in Splunk for Good. You can't publicly display tweets without using Twitter to do that, because you actually have to have all the web controls to make it publicly accessible. That's not even true. A Tumblr post, right? Because 7 years ago, go there, you're going to get a login. But if somebody says, hey, it'd be really cool if you guys did this, well, you can do that. This is datasif.com. You know, we're them and their competitor GNIF, who's owned by Twitter, we have direct integration with them, so DataSift can push directly to Splunk. And then I built modular input, SIF and GNIF. They're available on Splunk if the system can't push to you because of firewall rules or whatever. Other thing you can do if you're ever interested is, yeah, it would be great to see what's happening in the stream, but I want to go back in time and look over last year. So we're working Oxford that are doing social media research on this is our Splunk for Good account. They're doing social media research on Ebola. And accounts so they can do some stuff, but DataSift has this idea of a historic when you want to go back in time, you wouldn't want to just say, hey, give me everything that has the word Ebola in it for the last year. Because it's 10 cents for 1,000 tweets is how much a tweet costs. So it'd be like, 100 million tweets, which is considerably expensive at that point in time. Although you can do some cool things like creating your own 1% feeds. But historical preview lets you take your stream terms and then feed them to DataSift and say, go look over that month and see what was there. And this is sort of, it's a really powerful system. It has a monthly fee and a licensing fee, but of course, it actually has an easy to understand language as well. On how it is. It's pretty cool. If you're ever interested in social data, I mean, we don't resell their stuff. I can give you the email. They're salespeople. So. Good. Sure. Thanks.